Zulaga, and alongside Cadet Spencer and Cadet Harrison, this is our SE370 final project. As you can see here, our task is based on this company, Blue Bikes. Blue Bikes is a bike sharing service based in Boston, and they've recently decided to try expansion into the Fort Montgomery, Highland Falls, West Point area. This is their website, and as you can see, they have different affordable ways of getting around and a pretty self-explanatory way of bike sharing. So the project lead has given us a task of creating or helping the marketing campaign create possible promotions for the first year of this expansion. And we were given data for the previous last years of bike sharing for Blue Bike's sharing company, and we've tried to extrapolate the data and learn something that can help the marketing campaign have a successful first year. So the two data sets we were given, you can see here, they include age, employment, and date, as long as the total riders and different types of riding, and as well as the weather for that day. So we're going to start the presentation off by interpreting / exploring a little bit of the data, and then moving into the Shiny app we created. The first graph we have here is the total number of riders for each season, and it just takes the total number and the season, right? So the main takeaway from here is that summer is the greatest. In the summer months, we have the greatest number of total riders with the given current data. So that could be attributed, and it makes sense because most of our riders, to be exact, 55.2% of our riders are under the age of 25. So summertime is where these high schoolers, bachelor's program, and postgraduate students, they have more free time because they're not in school and stuff. So summer, it makes sense that this is where the greatest ridership is, and the marketing team can use this as they might need to. Next, we kind of confirmed this idea that we got from the first graph, and we plotted everything by occupation, and to no one's surprise, students ended up with the highest number, almost by double. So next, we plotted each different age group with the seasons of where they were riding. Then the trends were pretty similar. As you can see here, this is under 25, and the first three summers, autumn, spring, and summer, the first three seasons, autumn, spring, and summer, create this V shape, and then winter drops down, which nobody's surprised. Riding a bike is less likely, people riding bikes is less likely in the winter. However, it is important to notice that in this specific graph, students or people under 25 were still almost 300,000 in the winter times in terms of bike riding. But as you can see in these next couple graphs, this one being age 26 to 35, the same trend follows where there's a V shape and then peaking in the summer and then dropping to the lowest in the winter. However, what is different between these graphs, this one being 36 through 45, is the scales. As you can see to the left here, this one is 46 through 55. Again, same exact trend, just different scales. So to kind of get a better idea of the true amount of people for each level, because as you can see here, 55 is only 30,000-ish, a little 35 maybe, whereas compared to the 25 was 300,000 in the wintertime. So we plotted them all over each other to get a better idea, and here red, again, under 25 is clearly above everyone regardless of the season. But the important thing as well is that it might be better to advertise more heavily during the summertime or spring to leading to the summertime, because this is where we can see across all levels a higher amount of bike sharing rides. So our next graph here, it shows the occupation of the riders in each different season, right? So again, this just shows that students, regardless of season, have the highest. But it does an important distinction between this graph. As you can see here, employed people in the summer are also much higher than any other season available with the data. So the marketing team could take this and potentially see not only are the students obviously the main priority, but then employed people should also be more of a priority during the summer or the fall, however they choose to interpret it. We just created the data to give them an easy way of doing that. This next graph is plotted to show the impact of season and weather on ridership. And as you can see here, fair days, which we described as any day with humidity between 25 and 75 and a temperature between 50 and 85. And that was where we saw the most amount of ridership. This came kind of as a surprise. We thought excellent day, where humidity was less than 50 and the temperature was greater than 70-ish, was going to be our main priority here in terms of ridership, but that was actually not true. So the marketing team could use this however they see fit. Next, we took the data provided where 1 through 4 were better days to worse days. And as you can see here, 1 is a better day in terms of our data and 4 is worse. And to very little surprise, the nicer the day, the more people that rode the bikes. This just shows you the amount or the level of difference between how nice of a day and the level of ridership. Our next graph and final graph was sentiment that we saw reviews from a website, or multiple websites, but this one specifically would be Yelp, where we took comments from, or we took every single review and then scraped all the words to get a general understanding of positive or negative sentiment towards blue bikes. And as you can see here, this linear regression line isn't a positive thing. This could also kind of give the marketing team an idea of how well we're doing with customer service now and how much we have to change that in the future. If we continue on this trend as predicted by this model, it's only going to get worse. So potentially there's room here for improvement that the marketing team can look into and decide what to do with.
So in this portion of the video, we're going to be going through the Shiny app we created for the Blue Bikes case and the analysis of their ridership and future marketing. So to create this app, we created 2 portions of code that would go into our Shiny function. The UI code established the interface we see for the app to include the navigation bar options, these tabs that we see, as well as these sub-tabs that we can click on to arrive at different plots. To go over some of our plots that we see in the app, these were brought about by the second portion of the Shiny app code, the server function, and each of these plots is brought about by an output that is included in the server function, which consists of the ggplot code in order to produce each plot. So we included all of our plots that categorize ridership according to season, and we can see here that we did them via information about occupation status and age group status. So to see occupation, we notice that the greatest number of riders belong to the student category. And then when we move on to age group, we also notice that the highest number of riders belong to the under 25 and the between 26 and 35 age groups, and the highest number of riders according to age group occurred in the fall and the summer. When we look at weather, we see that the greatest number of riders rode on days that we categorized as fair. But this did also apply to the under 25 age group, was the greatest number of riders. And then using the classification set by the data, we noticed that, in the fall, we also had the same number of riders, and it belonged to days that they classified as 1, which would be the best days that Blue Bikes considered in terms of weather. Going on to demographics, we noticed that our greatest number of riders rode in the summer, closely followed by the fall. And then we also noticed that our total number of riders significantly lied in the student occupational status, followed by employed, and then there were a few unemployed riders. And then our final tab is an analysis of sentiment of reviews of Blue Bikes on the Yelp app. So we can see that sentiment slightly decreases as the review number increases.